All right. Hey, Chem 20s. Today is Wednesday. If you want to use today to do the unit test, quote unquote unit test, use today's class time. If you're done and you want to move on, we're going to be talking about limiting reagents for the rest of this week. So I'm keeping this lesson really short. It's just going to be an introduction. Up until this point, we've talked about limiting and excess reagents in general terms. And a lot of reactions were like, we're mixing this chemical with an excess, so we don't have to worry about it because there's so much of it. Well, now we are going to be getting into situations where you have to figure out the substance that you're going to run out of first in a reaction. I use the example like you are making sandwiches for a picnic, and there's lots of people, and you have 20 people, so you need to make 20 sandwiches. You've got 40 slices of bread and 7 pieces of cheese. You probably can't make enough cheese sandwiches for everybody. So cheese is your limiting reagent. In chemistry, the cheese is the moles. When compared fairly, when you have moles that run out, that is the limiting reagent. So just quick definitions here. The two things are limiting and excess. Limiting are the mole or chemical amount that will run out. An excess will have moles left over after the reaction stops. So if you want to think of that example I gave you, we have 20 people. So we have to make 20 sandwiches. Right? How do you make a cheese sandwich? Well, you need 2 bread, right? 1 slice of bread, and 1 cheese. Now, this isn't balanced properly, but the idea is that if we think of it this way, we would need 40 slices of bread to make 20 sandwiches, right? Because in order to balance this, in order to make enough sandwiches, you'd need 40 slices of bread. And the example I gave you, I think I said you had 6 pieces of cheese. Well, you would run out of cheese, and it doesn't matter that you had so much bread. The reaction would stop at 6 sandwiches. You'd run out of cheese. And that's how chemistry works. Okay, so all we're going to do today is compare when we have moles. It gets a lot trickier when we're comparing masses. We're just going to start with moles. And mole comparisons are the easiest to do because they take one quick calculation and then you've figured out your limiting and excess. It's going to get tougher tomorrow and it's going to get tougher on Friday, but we're just starting easy today. So here we have 20 moles of methane and that reacts with 20 moles of oxygen. What is the limiting reagent? The limiting reagent is always going to be the smallest moles. When compared equally. So what a lot of people do is they see the smallest number and they're like, oh, this is the limiting reagent. Now, that may be the case. You've got a 50-50 guess every single time you do this. So if you forget how to do limiting reagents and you got to figure out which one of the two is the limiting, and you're like, dang, I forget. Oh, dip, I forget. You just pick the smallest number. You could be right. You'd be right 50% of the time. What does it mean to be compared equally? Well, this is balanced for 1 mole of methane and 2 moles of oxygen. So the easiest way to do it is to take the largest chemical, like the largest balance, and just divide this by 2. And when you do that, you have to divide this by 2. And we've divided this by 2, so we're going to divide this by 2. So we get 10 versus 5. Yeah, and that is the limiting reagent. This is the limiting reagent. The idea is that we would need probably to make this a fair reaction, we need twice the amount of oxygen as we need of methane. We need twice the amount. So we would actually need 40 moles of oxygen to react equally with 20 moles of methane. So there's lots of ways you can compare this. You could just look at it and figure out, oh yeah, but we need twice the amount. So we really have half the amount in a fair comparison. Okay. Oh, I made a mistake here. We would divide this by 1. We divide it by the coefficient in front of it. Okay, my bad there. Well, I'll show you that on the next one. So it would be 20 versus 5. Okay, let's try another one. Okay, so here we have 2.2 moles of magnesium reacts with 3 mole hydrochloric acid. What's the limiting? Okay, so we got magnesium solid plus hydrochloric acid. This is a single replacement. We get magnesium chloride and hydrogen gas, and then we have to double it. Okay, so we have 2.2 mole of magnesium, 3.3 mole of hydrochloric acid. Now, it looks like magnesium right off the bat is the limiting reagent. It's the smallest number. But remember, this reaction has, when we balance it, we need twice the amount of hydrochloric acid. So one way you can do that is say, if I used all of my magnesium, all of the magnesium, how many moles of hydrochloric acid would I need? Well, I would need twice the amount, 4.40 moles of magnesium. And of hydrochloric acid. And do you have 4.4 moles of hydrochloric acid? No, you only have 3.3 moles of hydrochloric acid. So that's one way you could figure it out. The other is you could quickly do the quick division where you divide this one by 2 and this one by 1. You divide it by the coefficient that's in front of it. So 3.3 divided by 2, we get 1.65. And then 2.2 divided by 1 is 2.2. So when compared fairly, based on what their coefficient is balanced for, this is the smallest number. Okay, so you can just kind of look at it and move the numbers around and say, if I was to use all of this, how many would I use? And so on and so forth. Now, I made a mistake back here. I apologize. You divide by the coefficient. I don't know why I put a 2 down here, but you do divide by the coefficient. I guess that's a tough thing when I'm teaching, when I'm making a video, is nobody in the audience is like, wait, that didn't make any sense. But anyways, that's how you do it with moles. Okay, I'm gonna give you guys one more. So we got S8 plus oxygen gives me SO2. Whoop, SO2 gas. That's a 2. Okay, so 8 there and 8 there. Okay, let's say we had 100 moles here and we got 700 moles here. Okay, right off the bat, it looks like sulfur has the limiting reagent because it's got way less moles. But the idea is, if we used all 100 moles of sulfur, right, and we times that by 8, we would need 800 moles of oxygen. And we don't have 800 moles of oxygen, we have 700. Or, if you don't like that way, you divide by the coefficient. Divide this by 8, because it's balanced for 8. Divide this by 1. Now, if we're just figuring out the limiting and the excess, last time I checked, if I took 7 and divided it by 1, or 7 divided by 8, it's going to be less than, it's going to be a decimal, right? And 100 divided by 1, okay? But if you want me to do the math, I will. So 700 divided by 8 gives me 87.5. This is 100. 100 divided by 1. That's a bigger number. This is the limiting reagent. Now, this quick calculation, dividing by the coefficients, relies on you balancing the reaction. Okay? And all we're determining right now is what the limiting reagent is. The math is going to get a little trickier tomorrow. Remember, all we've done is when we're comparing mole to mole. Tomorrow, we're going to compare mass to mass. So there's a couple little extra steps there. All right, that's the video.